Hey everyone, Mrs. Spatola here. We're starting Unit 4, Factors. And if we take a look, you can get a pretty good idea of what's coming up in this unit by taking a look at the lessons 1 through 10 here. We're going to look at prime and composite numbers, number theory. This is pretty cool. Prime factorization expanded in exponential form, making factorless t-charts. We've actually done something similar to that, so that should be something you're familiar with. And then we're going to look in lessons 4 and 5, we're going to look at the greatest common factor, a couple of different ways we can find the greatest common factor. Then we're going to apply the greatest common factor to simplify fractions. That's what we're getting ready for in Unit 4. Getting ready to handle those fractions, boys and girls. You're going to love it. And then finally, we have some greatest common factor word problems, some tables, and some review. Let's take a look at the first lesson, prime and composite numbers with number theory. Unit 4, Lesson 1, Factors, Multiples, and Prime and Composite Numbers. How can you find factors, multiples, prime, and composite numbers? In this particular lesson, if you take a look at our little info box over here, we're going to be taking a look at factors. I think this is something that looks quite familiar to most of you. Here, if you remember, what is this kind of a chart called? We call this a T-chart, if you recall. And basically what this T-chart will show us are all the different factors of each of the numbers. So for example, the first number is 16, and then basically what we're going to be doing is figuring out what numbers multiply out to 16. So for the first one, we can see it's 1 times 16, and then we have 2 times 8 and 4 times 4. For 24, it's 1 times 24. Then we have 2 times 12, 3 times 8, and 4 times 6. And lastly, factors of 15, 1 and 15, 3 and 5, and we are done. So this is what we're going to be looking at in this particular lesson. For set A, they want you to list all of the factors of the following numbers. We have 2, 3, 5, 7, and 11. I'm wondering if you notice anything right off the bat. Well, if I look at these numbers here, I notice that the factors of 2 are 2 and 1, 3 and 1, 5 and 1, 7 and 1, and 11 and 1. Notice anything unusual about that? I wonder if you notice how many different factors are there for each of these. There's only 2 factors. Good job. Let's take a look at the next couple and see how many factors there are for those. For the next set of numbers in set B, we notice that we're going to be listing all the factors. So for 4, it's 1 times 4. And then 2 times 2, so we're just going to leave it there. For 6, it's 1 times 6, and then 2 times 3. Notice this is a little different. We did the T-chart in class. I definitely like that better. This method, by the way, you may have heard in the past, has been called the rainbow method. I don't know if you've ever heard of that. So it's 1 times 6, 2 times 3. Let's take a look over at 9. It's 1 times 9 and then 3 times 3, but you only list the factor 1 time. So here it would be 1 times 9 and then 3 times 3. Let's look at 12. 12, we have a few of them. And lastly, for 12, we have 1 times 12, 2 times 6, and 3 times 4. So again, if we call this the rainbow method, it's 1 times 12, 2 times 6, 3 times 4. Okay, let's keep going. Now here is the T-chart. This, to me, is the easiest way to list all of the factors. And you go in order. You start, so for example, for 6, we have 6 here, but we also did 6 up here, right? It's 1 times 6 and then 2 times 3. So all of the factors we can count are 1, 2, 3, and 6. And if you go on for 12, It's pretty much the same thing. It's 1 times 12, 2 times 6, 3 times 4, and then the factors then become 1 times 12, 2 times 6, 3 times 4. So we have 1, 2, 3, 4, 6, 12, and there are our factors. Now, what do you notice, or what difference do you notice between set A and set B? Well, obviously in set A, you can see that there were only 2 factors in each of the numbers, whereas in set B, there were at least 3 or more factors, which happens to lead us right into something pretty cool. That would be prime numbers and composite numbers. A prime number is a whole number with only 2 factors, the number itself, and 1. So therefore, the first set, set A, was a list of prime numbers. So set A was prime numbers. That was prime numbers. So set A was prime, and that's set A. And then set B would be a list of composite numbers. That's a whole number that has 3 or more factors. The numbers 1 and 0 are neither prime nor composite. So we actually call them something a little different. So if something is not one nor the other, what would they be considered? Well, basically, they're considered neutral. Alrighty, let's take a look at some examples. Are the following prime or composite? So again, prime numbers only have 2. They only have 2 factors, 1 and itself, whereas a composite has 3 or more, or 3 plus. So let's take a look at the first one. 20, does that have more than 2 factors? You betcha, so that's a composite number. The number 29, how many factors does that have? Well, I know it's 1 times 29, but I know there's nothing else, so that, boys and girls, is prime. So I'd like you to pause the video and go through the next 5 by yourself. Pause the video now. And there you have your answers. Number 14 is composite because it has more than 3. 33 is composite. We have 1, 3, and 33, and 11 as our factors. 31 is prime. It's only 1 and 31. 65 is composite, and number 11 is prime. I'm going to ask you to memorize the first 8 prime numbers. And those numbers would be as follows. Those numbers would be 2, 3, 5, 7, 11, 13, 17, and 19. Let's keep going and see what's next. So in your workbook on the next page, we have the directions say, circle all the prime numbers between 20 and 49 below. So you're going to go through and circle only the prime numbers. Pause the video now and try it on your own. Good luck! And there you have all the prime numbers between 20 and 49. After number 25, boys and girls, over here, can you please cross out this one? It's 25. That should read 26. That was a typo. So in the 20s, we have prime numbers of 23 and 29. Then we have prime numbers in the 30s, 31 and 37. Lastly, we have in the 40s, 41, 43, and 47. Let's keep going. Circle all the composite numbers between 80 and 90. Now you're going to circle composite. Try that one on your own. Pause the video. Good luck. And as you can see, the composite numbers in this section would be 80, 81, 82, 84, 85, 86, 87, 88, and 90. Now, you might look at a number like I did. For example, 87. I know that's an odd number, and I'm trying to think in my head, okay, what number goes into 87? Well, I really couldn't think off the top of my head, but then I said, wait a second. I learned in Unit 2 we learned about divisibility rules. So guess what? If 1 times 87 are two factors, if I add 8 plus 7, what do I get? Right, 15. Can 3 go into 15? You betcha. So guess what? 87 is divisible by 3, therefore it is composite. Sometimes these get a little tricky, but think back to your divisibility rules. Remember, if you need to look back, you can look back in your workbook, back in Unit 2. The next thing we're going to talk about is multiples. And multiples are when we skip count. It's the product when a number is multiplied by a series of consecutive numbers. That's a huge word, boys and girls, to remember, consecutive. It means one after the other. I believe we've talked about it in class before, but you definitely want to know what that means because we will be using it again. So think, when factors are few, on the other hand, we think about multiples being many. And we think about M&Ms. Do you want many M&Ms or you only want a few? You want many. So M&M multiples many, M&M multiples many. So get that into the registration of the brain and we will see that multiples are many. Next, write the next 9 numbers or multiples in the pattern. So basically what's going to happen with the next ones, you're basically writing out your multiplication facts. So give it a shot, see how well you can do, and you can use this to help you to memorize your multiplication facts as well. I'll do the first one with you. So the first one is 4. So basically you're going to write the multiples of 4. So we have 4, 8, 12. Now I notice that we are definitely skip counting by 4s. So I know I'm going to go 16, 20, 24, 28, 32, 36, and 40. And then I have 44 and 48. And that basically brings me out to 4 times 12. The last number here, the last digit is going to be whatever your beginning number is times 12. Alrighty, try the next ones on your own. And there you have all of the multiples of 5. Now remember, multiples, you're skip counting. Multiples, many. You're skip counting by whatever you're starting with. So this is going up by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and 60. Hope you did well with that one. Let's move on. Let's try the 6s. Pause the video, give it a shot, and then restart to check your work. And there you have all the skip counts for 6. Pause the video and try the remaining on your own. And there you have all the multiples of 7s. Keep going. And there you have all of the multiples of 8. Remember, multiples mean to skip count. Multiples, many. Try the remaining 3 on your own. You're going out as far as 9 numbers each. Good luck. And there are the answers for the rest of the multiples of 4 through 12. Hope you did a good job. And on the next page, this is going to be your homework. You're going to go through for prime and composite numbers. You're going to classify each number as prime or composite. There is a hundreds chart on the first page of the lesson that we started. And you're going to go through all of these. For example, number 1, 53. Is that prime or composite? You should all know that that is a prime number. So you could check that off, shade in the box, however you want to do it. And you're going to go all the way through to number 40. When you're done, just take a look at the next page. This last page is going to be a challenge page in your workbook. Please take the time, do it at home. You might want to pull it out for your family. You'll be off for quite a few days this week. So try puzzle number 1. It is a math challenge, and you're going to travel from start to finish in no direction, and you're going to read the directions and try to get to the finish line to get to this number 79. In number 2, puzzle number 2, here's another challenge. Twin primes are a pair of prime numbers that have a difference of 2. How many pairs of twin primes are there less than 100? Try your best to answer that question. Now, it is a multiple choice, but what you need to do is list all the pairs below, so hopefully that'll help you. Remember, the twin primes are a pair of prime numbers that have a difference of 2. Good luck, everyone, and have a great day.